Okay. Hi, everyone joining us virtually. I'm super happy to meet you all and welcome you to this webinar in our Agentic AI and Engineering series. Previously, we talked a lot about applications, and today I'm super happy to have Vlad with us from Accenture, who has a lot of insights and experience working in Gen AI for engineering and is here to share his insights into this whole domain. Vlad, happy to have you here. Few words about yourself to our audience here.
Yeah, thank you very much for having me. My name is Vlad. From my background, I'm engineer, but I drifted pretty early in software development, was working as a full stack software engineer, and later had the opportunity to lead the software department in a company which did machine translation. And we were training transformer models as there was no term for Gen AI. So we were training small open AIs of this world in our basement. I was super fascinated by the transformer technology, so I wanted to go further in this direction, but with engineering. Later, I joined Umlaut, and we were acquired by Accenture. And for the past 5 years, my main topic is now industrial AI. So how to bring not only LLMs and Gen AI now, but the full variety of AI technologies and agentic architecture in the industrial world in a scalable and trustworthy way. So happy to join today.
Thanks so much, Vlad. So yeah, my name is Ram. I'm head of AI at Synera. So almost pretty same track like Vlad. Started with engineering, but with a background in AI. Also worked a little bit in NLPs and machine learning technologies. As of today, I work a lot with our customers, try to identify how do we shape up our agentic product here at Synera. And now we are interested to get to know everyone here joining us. And that's why to start things a bit interactive, we prepared a very quick poll for us to all exchange and express our thoughts. So please feel free to scan this QR code, and it should be a poll popping up on your website. And the question is, how familiar are you with AI agents and their potential benefits for engineering workflows? I see the circle is getting more and more equal. So let's see how it ends.
Perfect distribution.
Yeah.
Almost. Okay.
See, there's almost 23 people who participated. So let's give it a few more seconds so that everybody can scan the code and participate. Okay, I think more than half of us have already participated. And if we already look at the distribution, I think we have a couple of people who are already familiar with the topic. So I think this should be already relatable to some of us here, what Vlad is going to present. I see also a more leaning towards new topic. So we also have this covered. So we'll introduce what agents are, why are we talking about this now? And I see some people have already had some touch points. So given the fact that whole agent topic is super new, it's really interesting to see how fast these things are picking up here. But with that, thanks so much for your participation already. I'm pretty sure we have some engaging content here. And with that, Vlad, I would already like to hand over you. What have you experienced in the last few years in your work that you would like to share with us today?
Yeah, thanks a lot. Also great to see this distribution. So it's classical Gaussian bell curve. Yeah, we have some people who started to go deeper in the technology and experiment with it. So a few people who say they're pretty far advanced. I think we see the same pattern in general at the moment on the market across the Europe. Yeah, so I try to find a picture. What do we see when we talk at the moment to industrial companies, to our clients, having all the discussion? So at the moment, it feels kind of an ocean of use cases and POCs. Most of the companies we're talking to, they started very ambitious. generated a lot of use cases. And then on some point, you have a stagnation where you have a full backlog of ideas, a lot of POCs, trying probably everything and every application in the market, and then seeing that it's somehow not really making the click people expected. And also that the curve from a technology part is getting, I would say, rapidly very advanced. Yeah. So in the beginning, the first successes are very tangible. It's very easy to implement something like talk to some technical manual, talk to some knowledge management system. But later, the application of the large language models and all these assistants in the real processes, this is the main challenge for the most of the companies. And of course, very few processes are based on a greenfield application. So you have your normal set of application you already have. You have the data, you have the whole complexity of your processes, and this somehow should be connected to your co-pilots and to your application. And this is a major challenge. When we switch to the next slide, I would like to just briefly summarize where we're coming from, because some of you maybe know Accenture, some of you will be surprised maybe to see Accenture in an engineering webinar. But actually, we have a very large footprint in the industrial space. Accenture has 5 service lines, and we have a pretty new one, which is called Industry X, where we specialize on industrial consulting, but not only as a theory. We actually have engineering people. We have people from shop floor for over 20 different acquisitions. And in Germany alone, we have around about 2,000 people with engineering background offering engineering services. And of course, for us, topic of LLMs and GenAI was not a theoretical one. So we're actually really heavily investing in ourselves to become AI-enabled engineers to be more efficient and competitive. And throughout this activity, I think we did the same curve as most of you did. Yeah, the first, I would say, inspiration in exploration the cases. Yeah, finding a lot of cases where we can implement or apply LLMs along the V model. But the first question we had, and of course many of you as well, how you can scale from all these POCs to really new processes. So if we go to the next slide, I just summarized 3 main key drivers, I would say, which we currently observe in general in a space of industrial AI on the market. And we will go today in one of them, but I think in the future we'll see a lot of connectivity between these 3 pillars. The first one, we see a major trend into embedding AI into the physical products and robotics, automation, advanced automation, which we call physical AI. Then the major trend to virtualization, where a lot of the processes which we have, you can build before in virtual space or modulate them, simulate them. It's also super interesting for product development, physical product development, and also has a huge expectation, your data and engineering backbone. But the third component was particularly very interesting for us, and we're already using also for ourselves, is the area of orchestration. What do we mean by orchestration is that if you talk to ChatGPT, you've seen that for today, it's not only able to generate materials or texts or PLC code, it also can reason. So it can try to make some logical conclusions. And during this process, for kind of a new capability for the last 2 years, it can also trigger action or even use some tools. And this process where we have a large language models which can reason, so have some conclusion and decide which tool should be used in which way, we call orchestration. And this is one of the areas where we see the major impact for industrial space and particularly for engineering. Next slide, please. And some of people ask, okay, maybe we just should wait, and I would say we need some time until kind of ChatGPT 10 or 100 will solve our challenges in industrial and will be connected to my PLM and the whole data I have. My personal opinion that this will not happen. So there is approaches in the market, yeah, like with Claude, with MCP, where you can have your large language model triggering some actions in GitHub. But I would say it's a big difference of having software development lifecycle is DLC application with GenAI and MCP, or having your real engineering process where you'd like to embed AI assistants. In my personal opinion, it is because of three major differences in the industrial space compared to other domains. The first one, we have very diverse domains and disciplines which have to work together. And this is pretty challenging, as each of its domain and discipline has own unique syntax. And you cannot have one chat which connected to all these disciplines with different domains. I think you had already this experience. If you try to discuss with ChatGPT in one window your vacation plans with some recipes for your evening, the quality will drop. And there's a term for that, is context degradation. So you cannot mix too many topics in one syntax. So you have to split them into different environments, or you can call them also agents. The second topic is the fragmentation. So we have different tools, and it's not practical, I think, for most of you, to jump from one context window, from one chat to another chat, and copy paste all the time the outputs and inputs from window to window. So we need kind of a digital thread connectivity between these context windows. And the third problem is the syntax. So ChatGPT and all the LLMs are pretty good in coding in Java, JavaScript, and Python. But if you look at our syntaxes in interfaces and programming languages for our tools, they are very specific. They are not so well documented. There are also different versions of that, and LLMs perform much worse in these environments as in other domains. So if we switch to the next slide, what we've seen on the market is that over past year, each vendor provider, each solution came out with some idea for Copilot. Yeah, it's kind of a low-hanging fruit. It's easy to get, that you can generate a lot of value wrapping a LLM interface around any tool. Yeah, you can ask questions. You don't need anymore this button F12 to get some strange support, which will help to your provider, to your question. You can really talk to our application. It helps in many areas, but it's not really changing the processes. So we distinguish between vertical integrations and horizontal integration. The vertical, where you go with your co-pilots in one discipline deeper, like, for example, having co-pilots for model-based system engineering, where you can generate value, but you will end up with just another tool. Yeah, we'll have another co-pilot with already hundreds of tools you have already in your portfolio. We believe that real challenge comes not only with the vertical integration, but actually with new processes behind. So how good is this reasoning and the LLM capabilities are integrated in your whole processes horizontally? So we call it horizontal integration. And you probably heard the term of digital thread. So we call this integration of reasoning capabilities in the digital thread, digital reasoning thread. So how it can be possible not to skip from window to window, to have one interface which understands your task and where you can iteratively solve your problems, no matter which tool you use. The answer to it, if I switch to the next slide, for ourselves was a concept on which we work now. As I mentioned, we call it digital reasoning thread. So what we started to do is to define, I would say, our expectation on such a platform. Yeah, so we have also one approach on ourselves and Accenture, where we connect our application to these processes. And if we just click several times, you will see different models which we defined. For example, you need a proper data foundation. You need the tool adapters to your application, which you use in daily work. Optionally, it would be great to have a low-code, no-code orchestration platform. Yeah, so you not hard code each of these plugins and flows. You can visually connect them, and especially non-developers can adjust them easily. Still, you will need kind of a user and role management platform. It would be great if you could compose reusable components out of these flows and package them and reuse it in other tasks. Important, you have kind of triggers to start them. Yeah, and you can use these triggers to automate processes. And what comes new in our direction is also for ourselves that our intention is to scale it leveraging agents. So we would like to give these hooks and these tools to these agents so they can trigger these actions. And on the end, especially industrial and engineering, we have a high expectation on traceability, on on the audit of the processes. Yeah, so all processes has to be trustworthy, transparent, and explainable. And this is a major challenge in industrial. Yeah, this is very different, I would say, to marketing cases or to the cases, I would say, in even purchase, where you have a one format, you have one process, and you can just wrap LLM around that. And maybe if you look at this map, you will see, say, like it's super theoretical and we will be there in 5 years. But why we talk with our colleagues from Synera was, and we go to the next slide, is actually that Synera, for example, have already all these models, and it was really an exciting discovery for us. We also approach these models, but I really like the approach by Synera, how they combine it, starting from the data foundation to the low-code, no-code platform, creating these components, and later going to the agentic. I think it's a really unique approach in the market. And we decided to take together this topic to this webinar and discuss this approach to you. So on that slot, I will pass over to Ram and would be super excited if you could present how you approach this problem.
Yeah, thanks a lot so much, Vlad, for this really well summarized and digestible insights. I think what I learned from you was that there is a bigger, let's say, layer that's needed behind these agents to be working. And that is how this whole space could move forward. But before we go into the solution space, I want to hear from our audience here, again, to have a bit of an interaction. Another question to see how the impact is. So we are talking about automating processes, but I want to ask the audience here, how significantly do your engineering process challenges impact your organization today? And I think it's in the same Mentimeter link. So let's see how much insights we can get out of this poll. And the options vary from having minimal impact, which is having already well-integrated systems, or going more towards having everyday struggle and everyday integration issues and everyday pop-ups saying you have to close the application now. Let's see. I think there are 30 people and still half of them yet to answer. Let's give it a few more seconds, but I already see what kind of distribution would this be, Vlad? Maybe I pick your insights first. How do you see this distribution?
Yeah, I think it's already pretty clear, the trend. And this is the same gap we see in each discussion. Yeah, so especially at home trying ChatGPT, or if some of you code and you tried Cloud, Cursor, AI, any Windsurf, V0, any of this application where we see the power of agentic framework. Yeah,
Yeah.
Everyone thinks
Yeah.
that the application will be major if we will manage to make this bridge to make it compliant and with our real world tools.
Yeah, I think I also agree. I think almost 80% have almost more than moderate impact. And that's why I think the learnings are always the same. And thanks again for your participation. And now I would like to show you what we are doing in Synera to tackle some of these problems. Before we go into the actual nitty-gritties, maybe for the people who are new here, what is an agent? So an agent is basically a large language model with some context and some tools. So what it does is it takes in a request and it gives a response. Like Vlad said, if we ask ChatGPT, it's coming up with a response. But it has layers underneath it. So first it needs a large language model as the brain, and we need to instruct this model on the tasks to do. And to make sure these instructions and the responses are consistent, we need to make sure they have some memory. If they are sitting inside an organization context, we also need company knowledge, so they know how to respond, what to respond, and so on. And the last piece, which is always a bit tricky when it comes to engineering, is the engineering tools. And that is where Synera workflows come in as tools, along with other layers of building an agent. But when we put all this together, we have an agent that has communication and reasoning capabilities powered by LLMs, and it can also interact now with expert engineering tools. And if we zoom out and see how will this look like, and we are here talking about something where an entire organization could benefit. When we think about multi-agent systems, it's not just one task, but it's a complete AI workforce. That means, let's say we do have a multi-agent system that acts like an R&D organization. So we could pass it a requirements to this. And what would happen is at the first layer, there are what we call the management agents. And these management agents are predominantly making sure they are coordinating information, they are already passing the right context between one another, and are also talking to humans and getting feedback from them. So these are the agents who are predominantly more, let's say, reasoning about outputs and make sure the right decision is taken. And one layer below them are the engineering agents. And the engineering agents are basically equipped with expert knowledge in all these domains and silos that exist even today. And these agents make sure that the engineering reasoning is correct, make sure the validity is always correct, and ensure quality. And these engineering agents have their engineering tools as Synera workflows. And these Synera workflows are basically connecting different um, computer-aided engineering tools, software, and every agent has their tool. And when we now give a requirement to this whole system, we get a solution that's fully validated, is grounded in physics and engineering, but still is fast enough towards the whole process. Now, how do we go there? And that's why, like Vlad mentioned, we need a very strong foundation to start. We are seeing right now a lot of organizations proceed here, and the way to start with engineering would be a 4-step approach. So first, we would need some way to model our existing processes, and that's where a technology like low code helps. For us as engineers, it's always, let's say, a bit tricky to face Python errors every day, but having a visual medium to build these processes is much elegant. But once we have these processes, we need to make sure it already connects to the existing tool ecosystem. And that's how we have a marketplace, which we'll see later, where we are already connecting to major vendors. And once we build this process, we need a sustainable way to scale them so that it's not just a one-time automation, but something that could keep on scaling. And once we have this foundation layer, then we could connect them to agents so that they can now autonomously control these processes and also work with humans. So a short demo of how Synera looks like and how it all works. So this is Synera. On the left is a canvas, and on the right is a 3D viewer. And what we can do on the left is basically put our processes, digitalize them. So for now, let's build a simple multiplication process. So it looks like this. So on the left, there are inputs, and on the right, we get the output of this process. Now, we also have a lot of engineering data capabilities, where we can import them. For example, we need to connect Excel or CAD. We also can build all the engineering formulae, let's say, and all the other engineering tools. For example, let's take a sphere. So let's say we want to build a sphere with a certain radius, and we could already connect it. And now we see the sphere is a process. And if we keep on continuing this in the same way Vlad explained his digital reasoning thread, we have a digital tool thread, and we see the mesh connecting into the same process. So the data keeps flowing. And now what we can do is connect more and more tools. And at the end, what we will have is a nice way to encapsulate a lot of these. So it could either connect to the Altair system, it could connect to a bunch of different ecosystems, and we see how these all could work together. Now, a key point in these kind of automations would be how do we now expose them? And we need to make sure that these automations are not just lying on the platform, but they are used. So Vlad mentioned having these hooks where we can call this automation so that we can reuse them. And now what we will do is convert this automation into something that can be called. So what I will do now is make these as inputs for this automation and then expose an output. I could also just make sure this is visible in my automation. And then I could say, how do I want to connect all of these things and basically save it and then publish it. When I publish it, what we get here is an automation. And now we see it's not the same interface anymore, but we could run our processes here much elegantly. So this is how we could scale automations. Now, the reason the scalability aspect is so important is, like Rod also pointed out his challenges, what he saw or what we see. First, we need to standardize a lot of processes. So we need to make sure everything is stable, things are getting unified, and this is the foundation for agents to use. We also then, as we saw, we need to have this data flow and also need to connect automations that are lying in different domains. So not just engineering, but also business systems. So this is always a process that needs to be connected. And the last critical piece is the human in loop confidence. So we always need some kind of governance systems by which we can know, okay, what agent is doing what automation is at what state, what are the rights that everybody has. And this is basically what we call Synera run before we go to agents. And to show how some of these looks like, what we have in Synera is two kind of personas, where consumer is the people who consume automation, creators are the people who create these automations. So as a creator, we get a lot of, let's say, control over who is having my session, when was it started, how long is it running, and we also have complete control over this automation. And then I, as a consumer, as a human who wants to use this, I can just go into them, interact these systems, and make sure I have an automation as a mechanism to monitor these things. Now, we saw how we could scale automation, but one thing that also we learned at Synera was that we need to determine what kind of automation or AI is suitable for which task. So we classify it on a two axes. So one is the autonomy, and then the human-like or task fuzziness. So when we have a process that's highly rule-based, that it always follows the same pattern and it doesn't need any challenges, we could always go to rule-based workflow. So we actually don't need agents. When we need agents is when we want more human-like reasoning, and also let that agent decide, should I use tool A or should I use tool B? And like we saw that there is this context degradation problem when we try to connect a lot of domains together, a lot of tools together, the data loss is very evident. And that's why we go for multi-agent system. And these multi-agent systems are really useful when we are trying to connect not just one domain, but a wide range of domains and at high frequency. And this is where multi-agents can really excel. So with the low-code platform and with the scalable automation, we can now proceed to tackle bigger challenges. For example, an RFQ. So if we look at an RFQ process, typically, let's say for this automotive part here, it looks like this. We start with commodity analysis, where we see the moment a request comes in, is there anything that already exists in my system? Then we need connectors to these tools. We also need to see, okay, next step would be, how do I put this into assembly? What kind of manufacturing techniques I need, and so on. Again, we need a different set of tools for this. The next step to going into the business world is we need to see, can we deliver this order, and can we make sure the other processes like purchase and supply chain options, how do they exist? And then we need another tools for that. And then for cost analysis, we need robust tools like Facton or so to make sure the cost estimate is correct. When we try to put all these processes together, we see that we need so many different tools. And that's where Synera's marketplace helps, because our marketplace, like we saw previously, already has almost 65 plus technologies. So that means 65 plus different data objects, different integrations have been made possible. So you can just plug and play and drop them into your agentic workflow or your automation workflow. And now when we put all these pieces together, we see how this orchestration that Vlad mentioned could be possible. So here we see a multi-agent setup almost ready. So I have this commodity agent, the CAD agent, the assembly agent here, and also a purchasing agent, and then finally a costing agent. And at the top of this sits a supervisor, which is this management that we talked about, who coordinates and routes all the different things. And now we can simply connect these agents. We can also determine who talks to who. So the commodity can talk to CAD can talk to assembly agent can talk to purchasing agent, and finally they all can talk to each other. So this real orchestration becomes possible, and with a low-code platform with drag and drop agents, we can already build this. Now let's already publish it as another system and see how we can start using them. So again, I will save my workflow now as a multi-agent system, put in a description, and I could already publish them. So as soon as I publish, we now also get a more chat interface. So let me start a new session now. So we see that the agentic system now already comes with me with an introduction. So what can it do actually? And now I can put in an engineering requirement, and it is not going to reply me in text now, but it will take these requirements and actually operate engineering tools. So I just put in a request for a part that we built, and now we see the supervisor is starting to think, it's starting to work, and it says, okay, I understand what you have done. I need these requirements, so I will coordinate with other agents. And now we see the commodity analysis agent is using an engineering tool to get the answer without having to generate just text. So it got all the needed dimension, what kind of parts. Did it also find it in the database? And once this has been found, then the commodity analysis agent reasons itself to see, did I achieve my goal? What did I achieve? What do I still need? And then it passes, this information is passed next to CAD agent. And the CAD agent's focus is only for making sure CAD is needed. And again, in the same way, every agent owns its domain and all the tools are connected. So we see also the CAD agents output now. And then in a similar way, if we keep going, all agents would do their reasoning analysis. And finally, we come with this conclusion. And now we can keep challenging the system and keep exploring ideas. So I can ask, can you compare the codes for 2 different production volumes? And now we see that instead of starting the whole process again, it starts with the costing tool. So it knows that I don't need to talk to all other agents. Let me just start with my costing. And here are all the different costs. What are the supply risk for each of these options? And how do we proceed with all of this? So that was basically how this orchestrator with all other foundational blocks we can put together and achieve this orchestrator effect. And to summarize what we saw today, we know that for agents to work, we need a lot of different mechanisms or steps. And the ultimate goal that we want to achieve is definitely efficiency, collaboration, and of course, more creativity. But to go there, what we need is a more bottom-up approach where we first need to go to our data, our sources of data, and we need to see what are the different tools that we use in engineering. And then we need a mechanism to combine them. And there we see a platform like Synera with its low-code foundation would help in this connectivity layer. And of course, in Synera, you can build agents, but only after these kind of scalable automations are available can agents really use them. And then we realize the benefits of how we could make sure that agents in engineering are not just hype, but actually could be applied into our different organizations. So that is how we saw how some of the problems that the fabulous team at Accenture is working on and how our solutions could fit in. And I'm pretty sure if this is exciting to you, if this is a solution that could solve a lot of your problems, feel free to also engage with us more. We are talking more about this also with Accenture and a lot of other market participants on the Future of Engineering Summit, and Synera is also hosting this. We have a great panelist of people who have already done agents in engineering. There is also more information on the digital reasoning thread that Vlad talked about. So if you're someone like me who wants to know how things behind the screen look like and how the bigger concepts could look like, definitely do check out the digital reasoning thread. And if you're, again, looking to know more from a real customer, how they implement these strategies, I would also love to invite you to our webinar with Goetz, one of our customers. But for now, I think I also talked a lot now, and we should definitely have a Q&A session. And me and Vlad are really looking forward to answering some of your questions. So let me open the chat. And I think I saw that Vlad, you already answered one question, but do you want to share more thoughts, maybe verbally? What did you want to convey? And I think the question was about how this flow would look like.
Yeah, I think the question was in the beginning, especially as it showed, I would say more parameterized approach here, without any AI in the beginning. It was a way how you can create these models, which you can just adjust by using parameters. And the question was, where's actually AI in the space? And I just said that it will come later, and then was your part.
Okay.
So I
Okay,
think
great.
I should
Thanks.
answer.
Okay, yeah. Yeah, like I think that's also the right order how we do now agentic automation. So we start with the foundational layer. We see what kind of benefits already automation rule-based bring, and then we go behind this more human-like task where actually we need more agentic value. I also see a question by Elko, which says, how is the most relevant model and prompt chosen? Are these agents and orchestrator also available in marketplace or customer specific? Maybe Vlad, you answer how you choose or how one should choose a relevant model and prompts.
I think it's a good question because maybe you can also, when I'm ready, explain a bit more your approach with agents. Maybe it was not very clear that you define tools. Yeah, so this flows, which Ram just presented, will become your tools, which you can just activate. And then you can combine it with large language models you use. So for us, this topic of selecting the right model is a crucial one because it's not only the largest or the most expensive one. So we have own approach on engineer orchestration. The interesting part about that, our approach is actually vice versa. So we're starting on a reasoning capability, and we're connecting our agents to different tools and reason across them. That's why I think this discussion is also super interesting because I also like approach by Synera a lot, and I think it's depending on the task. If your task is very well parameterized and you can really define these flows, then this is a great approach. For us, it was very important to find the right model as well, because reasoning is something which involves a really large and I would say expensive models as well. But if you use AI and LLMs as a kind of AI API, then of course the I would say better approach is to use smaller models, which you can also fine
Yeah.
tune. So in our approach, we use smaller models as kind of executors. We call it executors
Mm.
or utility agents as the connectors between tools and the reasoning layer.
Yeah, I think I would also agree there. I think depending on the task that each agent has to do, we also choose our models. So for example, the supervisor has to reason better. And it has to have, I would say, a bit more context than everyone else. So we choose a model which could be having a bigger context window, or let's say a more reasoning oriented. So that would be the supervisor. And for the engineering agents themselves, it could be that we need a multi-model model strictly because they need to look at the results. We also need to see, okay, what kind of benchmarks that each of the model have. Are they getting better in multi-tool call, like the ability to use multiple calls in one go? Are they getting good at image understanding? So there are these metrics which we look at. So for sure, there can be different ways. And the prompt is something which we have figured out some, let's say, ways how different prompting could work. But what really helps is start with the simplest prompt and then keep adding more and more. So that is how prompt control. I think second part of the question was, does Synera have specialized agents? We have a lot of starting templates. So Synera as a platform is to make sure you can reuse a lot of things. So yes, we do have a lot of multi-agent templates already available for you to use. So that should be a very easy start for you. I see also another question by Yugen. Have you built your own agents that can validate intermediate agent results with a supervisor generating an audit trail of the entire agent chain? I think I understand it's more like maybe LLM as a judge, but Vlad, after you, what do you think? How how do you think agents do this?
Yeah, I think it depends a bit on your framework which you use. So for us, we work with different setups and different clients because if at the moment there's kind of a war of the frameworks in the space, and there are some frameworks like for example CrewAI or AutoGen where this function is even embedded. And I think if it's embedded on the framework level, then it's definitely a good approach. To build something like this by yourself can become very quickly very complex and also very costly. So if you try to build already agentic setups, probably you've seen how much of the token prices will go for this interaction between agents, and it's really impressive. So for all of you who didn't try that, just try to open any tutorials on LangChain or AutoGen, for example, and build your own small setup with agents, and you will see how complex this is, how quickly agents start to give each other compliments about great job without actually talking about the job itself. So if it's embedded on a framework level, yes, it's a great approach, and especially in, I would say, critical areas where we have guidelines, um, it's a way to go. But on a custom level, it's really challenging.
Yeah, I agree. I think at Synera, we started into this whole domain almost 18 months ago. And that time it was just LangGraph just came 3 weeks ago. So it was completely new. And then we had to take that. We need to understand what kind of trails do engineers need? How does the human in loop systems need to look like? So yeah, Yugen, to answer your question, I think it's not necessarily an agent. It can be just a mechanism by which we allow at Synera today to look through, okay, what kind of agent interactions happen? How did they reason? Where does the tool fail and so on? So these kind of auditing metrics. So I totally agree with Vlad. So it's more framework dependent, and jumping into this tooling layer is something that gets really fussy because every week something is changing.
Yeah, and what's, for example, super interesting to us, what we already use for our own engineering services is this evaluation of intermediate agents, because you can loop it again in the beginning. Yeah, so the system gives the feedback and you can iterate. So what we already do with all kind of routine tasks that we can run this agent overnight, for example, and have kind of a Monte Carlo simulation, across your different product designs. And on the end, you have verification, with validation, where you simulate the product, and you can run the system, for example, testing 100 different designs, and then you can on the end just get 3 or 4 designs which pass the requirement, and then with loops and iteration and reasoning really, I would say, unfold their real potential.
Yeah, I can only agree. I see a last question from Gerard, and Gerard asks, for step one, you need to model your engineering process with low code. Can the content be imported from sources like Aris? Um, yeah, to answer this, Gerard, we have an open ecosystem. That means if Aris is able to be connected via API, this connection should be possible. We also have a marketplace where you can also connect it to other tools. So as technically, because of this open API system, it should be highly possible. Okay, I see we are also just reached our time limit. Again, I just want to thank every one of you who joined, stayed with us through this engaging discussion. Thanks so much for your questions, feedback. I really enjoyed virtually interacting with you. And big thanks to Vlad for taking your time apart from all your existing things and really showing us how this digital reasoning thread could look like. On behalf of whole Synera community, thanks so much, Vlad, for joining us.
Thank you.
Okay, see you all. Bye.